cosec theta minus cot theta whole square is equals to 1 minus cos theta by 1 plus cos theta. Either you need to prove, so what you need to prove, which is LHS should be equals to RHS. Either you need to take LHS or RHS, and then you need to prove that they both are equal. Now I hope you got the question right. Now for my convenience, I'll be taking the RHS, that is 1 minus cos theta by 1 plus cos theta. Now we all know the rationalize the denominator concept, correct? So you need to rationalize the denominator, that is multiply and divide by 1 minus cos theta by 1 minus cos theta. Now what happens here? 1 minus cos theta whole square by a plus b into a minus b, 1 minus cos square theta, correct? Now taking this as a minus b whole square. So what is a minus b whole square, guys? A square plus b square minus 2ab, correct? And what is 1 minus cos square theta? Is nothing but sine square theta. By the identity, cos square theta plus sine square theta is equals to 1. So 1 minus cos square theta is nothing but sine square theta. Now we have got this. Now the next step, very important, you need to, the sine square theta should be given to all the three things, right? Now just divide it. Sine square theta plus cos square theta by sine square theta minus 2 cos theta by sine theta into 1 by sine theta. Now what happens? What is 1 by cos square? 1 by sine square is nothing but cosecant square theta plus cot square theta minus, this will go as 2 by cot theta. What is 1 by sine? Cosec theta. Now if you just look into this equation very carefully, you have something a square plus b square minus 2ab, correct? A is what? Cosecant, b is cot, and so it is in the form of a square plus b square minus 2ab, which is nothing but a minus b whole square. Now since I have taken a as cosecant square, I'll write a as cosecant theta minus b as cot theta, the whole square, correct? I hope you all got this. So what we can write is LHS is equals to RHS. Okay, now moving on to the next sum. Okay, now our next sum states 1 plus secant theta by secant theta is equals to sine square theta by 1 minus cos theta. Either you can prove it by separately, like both LHS and RHS, you can simplify and you can prove it, or else you can also do it in this method as well. Now I'll just take this LHS. Okay, so you know what is LHS, right? Now what is LHS? LHS is 1 plus secant theta by secant theta. Now we can write this as 1 plus 1 by cos theta by 1 by cos theta, correct? Now taking the LCM of numerator, which will become cos theta plus 1 by cos theta by 1 by cos theta. Denominator get cancels out. So what do we remain with? So we remains with 1 plus cos theta. Now what do we need to do? Rationalizing the numerator. I hope you know the rationalizing concept, right? It's very easy. So we are multiplying it 1 minus cos theta by 1 minus cos theta. Okay. Now what do we do? A plus b into a minus b, that is 1 minus cos square theta by 1 minus cos theta. So a plus b into a minus b is nothing but a square minus b square. So 1 square is nothing but 1 minus cos square theta. Okay. Now with the identity, that is sin square theta plus cos square theta is equals to 1, we know that. So what is 1 minus cos square theta then? Which is nothing but sin square theta by 1 minus cos theta. Look, we got our RHS. So what can we write by this? So we can show that LHS is equals to RHS, hence proved. Look guys, these type of sums requires some patience level before you start up with the sum. Please analyze the sum and then start with the solution, or else you'll end up with a mess. I'm telling you that. Okay. Now the next type of question. Now this is quite a bit of lengthy sum. What I can say is, okay, I'll just write the sum cos A minus sin A plus 1 by cos A plus sin A minus 1. This is equals to cosecant A plus cot A. This is the sum, and you can use the following identity, that is 1 plus cot square theta is equals to cosecant square theta. So you need to use this identity and you need to solve the sum. Now how will you go ahead with the sum? They have given in the question clearly we need to use this identity, but how can you use it here or here? Either in LHS or in RHS. Now how will you go ahead with the sum? Now if you carefully observe your LHS, that is your left hand side, we have cos A and sin A, which is nothing but 1 by cos by sin is nothing but cot, so 1 by sin is nothing but cosecant. So taking LHS, divide by sin A on both numerator and denominator. On both numerator and denominator, divide by sin A. Now what will be getting if we do that? Cos A by sin A minus sin A by sin A plus 1 by sin A whole divided by cos A by sin A plus sin A by sin A minus 1 by sin A. So what it gives? It gives cot A minus 1 plus cosecant A, and this gives us cot A plus 1 minus cosecant A. Now cot A plus cosecant A minus 1. Now how can I write this, guys? So can I write it as cot A plus cosecant A minus, now what is this 1? So in the question itself they are given, you need to use the identity, that is 1 plus cot square theta is equals to cosecant square theta. Now if I require the value of 1, shall I write it as cosecant square a minus cot square a? Can I do this? Whole divided by cot a minus cosecant a plus 1. This is a very lengthy problem, but if you do this, I think you can able to do any such problems, guys. Okay, now this is a square minus b square, so this is in the form of a square minus b square. Now we shall write it as cot a plus cosecant a minus cosecant a plus cot a into cosecant a minus cot a, that is a plus b into a minus b, whole divided by cot a minus cosecant a plus 1. Correct? Look at this step, guys. This is a very lengthy problem, I'm telling you. Now what is common over here? Cot a plus cosecant a is common, so I'll just take it out. Cot a plus cosecant a is common, and what will remain is 1 minus cosecant a minus cot a. Correct? And the whole divided by cot a minus cosecant a plus 1. So this is what we are remaining with now. Now giving this minus inside, so what happens? So we'll be ending up with cot a plus cosecant a into 1 minus cosecant a plus cot a, right? And whole divided by 1 minus cosecant a plus cot a. This whole things gets cancels out. Please have a check over here. This whole things get cancels out. You will be remaining with cot a plus cosecant a, which is nothing but your RHS. So LHS is equals to RHS, hence proved. So if you have any doubts in the steps, please go back to the video or just move just have a look on a previous time, like what we have done, so you can just follow the step by step. So this question requires a lot of patience and lot of focus, so please make sure you're doing that, guys. So if you're able to solve these kind of sums, rest of the things becomes very simple for you. Now moving on to the next problem, we have sine theta minus 2 sine cube theta by 2 cos cube theta minus cos theta. This is equals to tan theta. So this is LHS and RHS. So in RHS we need to prove that LHS is equals to tan theta, which is nothing but your RHS. Now how to go out with this sum, guys? Now if you just have a check, you have a common parameters, right? So take out the common parameters first, sine theta, and you will be remaining with 1 minus 2 sine square theta. And over here I'll remove cos theta, and you will be ending up with 2 cos square theta minus 1. Correct? And now what is this 1? 1 is nothing but sine square theta plus cos square theta. So sine by cos, can I write it as tan theta directly? And this is nothing but cos square theta plus sine square theta minus 2 sine square theta by 2 cos square theta plus into minus is minus sine square theta minus cos square theta. Correct? Now how do you solve this? Tan theta, you have tan theta. I have got this as cos square minus sine square. Correct? Theta, because plus sine square theta minus 2 sine square theta gives us minus sine square theta, and in the denominator what we have, 2 cos square minus cos square, we have cos square theta and minus sine square theta as it is. This whole things get cancels out, so what do you remain with, guys? It's tan theta. Look how simple steps, just by using your patience. I know some patience level will really fetch you an answer. So LHS is equals to RHS. We have got our sum. Okay, easy. I think it should really be very easy, but make sure these type of problems require lots and lots of practice, and every sum is unique. Okay, every sum is unique, so you need to practice every sum. Okay, so please make sure you're practicing it, and if you have any sort of doubts in the sum, please mention it in a comment box, so that in my next session I'll be dealing with your doubts. So if you have any doubts, please make sure you're mentioning it in your comment box. Okay, now the next problem, this is 1 plus tan square theta by 1 plus cot square theta. This is equals to 1 minus tan theta by 1 plus tan theta whole square, and this is also equals to tan square theta. Now we have done this problem, we have shown that 1 plus tan square theta by 1 plus cot square theta is equals to tan square theta in our first sum itself, right? Remember, our first sum was the same thing. Now what we need to do is we need to prove this, the middle one, that is 1 minus tan theta by 1 plus, sorry, this is a cot theta, the whole square is equals to tan square theta. Now how to prove this? Now this is what you need to know. Anyhow we have proven this, it was very easy. Now you need to prove this. Now just go ahead with the, now what is tan theta? It is sine by cos theta. And what is cot theta? It is 1 minus cos theta by sine theta. Correct? Are you getting it? Now taking out the LCM, cos theta minus sine theta by cos theta. Correct? And this is whole square, never to forget this, this is a whole square, by sine theta minus cos theta by sine theta whole square. Correct? Now denominator of the denominator goes to numerator, so in you just know that sine theta goes here and this comes here. Now what do we get? Which is nothing but cos theta minus sine theta into sine theta by cos theta into sine theta minus cos theta, and never to forget we have whole square. Correct? Now have a check. We have sine square theta by cos square theta, and cos theta minus sin theta by sin theta minus cos theta whole square. We have this. Now this is like in the form of, I'll just consider this and I'll just write it for you. I'll just show you how this thing works, which is a minus b by b minus a whole square. This is in the same thing, right? Now what is a minus b whole square? A square plus b square minus 2ab. And what is b minus a whole square? B square plus a square minus 2ab. So once again it's both the same thing and both the things get cancels out. So that is how these things get cancels out, and what you will be remaining with is only sine square theta by cos square theta, which is nothing but tan square theta. Understood? Easy. So please make sure you practice these type of problems very much, guys. If not, it is very tough to solve these things. So you need to practice it and practice more problems, because every problem is unique. Okay, so I hope you have all understood what are the problems which involves in trigonometric identities. Okay, so please make sure, if you like the video, and if you're a new viewer, please make sure you're subscribing it to my channel, and never to forget to press the bell button so that you'll be notified with all the new videos of mine. Okay, so we'll be meeting in our next session. So till then, make sure you practice the problems. Okay, take care, bye bye, and stay safe.